Let's talk about the circle problem. The question was, how many different sections are there in a circle if we put a certain number of points around the circumference of the circle and then connect those points with chords. So it turns out you may have seen a different number of sections than 31 when you drew your own circle, and we actually may all get different numbers depending on how you draw the circle and how you draw the points. So it turns out that in general there's nothing we can really say about the number of sections in the circle. However, we can talk about the maximum number of sections in the circle. And it does turn out that the maximum number of sections in a circle with 6 points is 31. So no matter what answer you got, you should not have anything that's more than 31. And of course that's assuming that you drew this with a ruler and actually had a nicely drawn circle and straight lines. Alright, so the maximum number of sections, we can say something about that. So what is the pattern? So we initially had one section, and then 2 sections, then 4, then 8, then 16, and then instead of seeing 32 sections, the maximum number is 31. So if the pattern isn't that the number of sections doubles each time like we expected, or maybe you predicted that, then can we find a different way to justify that the number of sections is 31? So it turns out there is a different pattern, and we can find it using a method that's called the method of successive differences. So basically we are going to subtract and do that repeatedly to try to see some sort of a pattern. Alright, so let's try this out. So you would subtract 2 minus 1 to begin, and then 4 minus 2, and 8 minus 4. So you're always subtracting a number a number minus the previous number. And then we end up with 15. Alright, so you may have done this before to find like a simple subtraction pattern. Now this one, still no pattern is really emerging yet with the differences. 1, 2, 4, 8, 15, right? So those are called the first differences, and you can kind of see why they're the first ones that we found. Now let's keep going to successive differences, meaning let's find the second differences, and we will do this by finding the differences between the first differences. So now we would do 2 minus 1, 4 minus 2, 8 minus 4, and 15 minus 8. Okay, and then finally let's go on, not finally, but next let's go on to the third differences. So we would get 1, and then 2, and then 3, and then lastly subtract again. So now we're on the fourth differences, and we get 1 and 1. Alright, so it turns out, write that down, third and then fourth. It turns out that if you can find a set of differences, in this case we had to go all the way to the fourth differences to see it, but if you can find a set of differences that are constant, meaning all the same number, then you can use those to work backwards and find the next number in the original sequence. Or in other words, what number would come after 31. Alright, so let's try it. So the fourth difference is if I use inductive reasoning here to assume that all of those fourth differences are going to be constant, since I do have 2 of them, 1 and 1, so maybe the next one is 1 as well. Right? Well, then that would tell me that the next number in the third differences, after 3, if I work backwards, this would be 3 plus 1 is 4. Or in other words, what number would I need to put here so that when I do that number minus 3, I get that constant number 1. Alright, so to work backwards you would do 3. Now if we wanted to take this even one step further, it might be nice if we could try to figure out a formula or some sort of an equation to predict the number of sections in the circle for any number of points. So this method works if we want to build up to other numbers, but let's say that I wanted to know how many sections are in a circle with 80 points along the circumference. Well, I'd have to use this method. I'd have to do an awful lot of addition here to build in all of these differences all the way out to the 80th number in this pattern. So in search of a shortcut, let's start to see if we can figure out maybe a different way to discover what the numbers in that pattern are. So let's start with exploring what happens when we add lines or those chords into a circle. All right, so notice to begin with, if you just have a single point on the circle, right, then we just have one section in the circle. Right? And then notice what happens when you add a new line into the circle. Right? What it does is it, by adding another point there, it adds another section to the circle. We now have two sections. Right? But let's explore what happens if we have, maybe any number of lines in the circle to start with. Okay, so here I've added some points to the circle, and I've started to draw some of those chords or lines. And notice I haven't finished all of them, so we saw for 6 points we'd have many more chords if we were going to draw all of them possible. But I've just put a few in for now to start. So let's look at what happens when we add an extra line. So let's say I add one that goes from this top point down to this bottom point. All right, so what's the change there in the number of sections? Okay, well, without that line, looks like 1, 2, 3, 4, 5, 6, 7 sections. And if I add that, if I add that line in, okay, what has that done? Well, it's added another section. We've gone from 7 sections to 8. Right, so it looks like just drawing a simple line like that is going to add one more section. And similarly, like if I put the line maybe from here to here, connecting the bottom 2 points, now I've also added in another section, so I've gone from 7 to 8 sections. Okay, but that only considers lines that don't cross other lines when we add them in. So let's look at what happens if I add one from, let's say this top point down to this bottom point. Okay, so now how many sections? So now if you count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sections. So I've gone from 7 to 9 sections. All right, so it turns out that in general, the number of sections in a circle is 1, so that's the starting region. If we just had 1 point, we'd have 1 section, plus the number of lines, right? Since every time we add a line, it adds another section. And then plus the number of interior intersections. The number of interior intersections. So when I added that last line, we jumped from 7 sections to 9 sections because, first of all, I increased the number of lines by 1, right? So that adds a section. And then secondly, I added in an interior intersection, meaning when that line crossed another line, I added, an intersection in the interior inside of the circle. So that accounts for that second section. All right, so we jumped from 7 to 8 to 9 by adding that line. All right, so we don't have enough math quite yet to go from here to a formula, so I want to leave this, and we'll answer this question by the end of the course once you've learned a few more things. But what we need to do is explore counting problems to try to decide how many lines are in a circle with n points, 6 points, 7 points, n points, and is there a way to count the number of interior intersections in that circle? So for now, your curiosity will need to go a little bit unsatisfied, but just know that we would build from this sort of start of an equation, 1 plus the number of lines plus the number of interior intersections, and it is possible to go from there using a few other types of math to this equation, right? And to be an equation, I need an equal sign here, so this is the, I would need to fill this in, and this is the number of sections in a circle with n points. In a circle with n points. All right, so I'll leave you to check that yourself. But basically, if we wanted to determine the oh, let me say maximum here, the maximum number of sections in a circle with endpoints. So, in other words, when n is, say, 6, right, then if you were to substitute all of the n's with 6's, then you would be able to work out the number of sections, and this formula would end up equaling 31. Okay, or if you plug in a 7 for n, then this is going to turn out to equal 57. So that's another way to get to those next numbers in the sequence. All right, so I hope that answered a few of your questions about the number of sections in the circle. And like I said, we will just leave this for now. And by the end of the course, you will be able to figure out where this formula comes from and create this yourself.